Welcome back to Lab at Home with the Museum of Life and Science. We are so excited to be back with you here. As always, we hope that all of you will help lead our program with your questions and thoughts and ideas in the moderated chat box. So that's going to be the main way that I can talk with you all. And I hope to hear from you because it's much more fun when it's more of a conversation than me just talking to my screen. But I'm so excited to be back. It's been a few weeks and I'm excited to celebrate the World Science Day for Peace and Development. And it's a really nice kind of observation of all of the different ways that science advances people's lives, makes life better for people all over the world. It's celebrated internationally. So it's really cool to be broadcasting on this day. And we're going to kind of observe it by talking about a particular a topic of an amazing innovation, right? And we're going to be talking about ways to categorize, put into categories different kinds of this particular substance. Our main topic today is plastic. So we're going to be looking at different kinds of plastic. But before we start, I wanted to know if any of you, first I wanted to know, are any of you going to be doing our experiment along with me? It's always okay if you're just going to see how I do it and then follow along afterward. But I just wanted to see if anyone would be doing it with me. Oh, you are awesome. So we have at least a couple people. Oh, sweet. That's so much fun. Well, I'm really excited to do it along with you. That's one of my favorite parts of Lab at Home. Oh, we have a bunch of people. That's great. So before we get started, we'll talk about kind of what materials we have, and we will go through the steps of our experiment. We're talking about plastic. What is plastic? Or what is it made of? Or even if we don't know exactly what it's made of or how it's made or anything like that, maybe does it make us think of something? Do we have any examples of something that's plastic? It's something that's a huge part of our lives. It's really kind of this amazing innovation. It's such a big part of our lives. I know that I have used plastic many times today. Microsynthetic fibers. Isabella, I love that. So a lot of kinds of fibers that make up our clothing and lots of other things are made up of types of plastic. I love that. And that is a way that we could even define plastic. It is kind of, in a way, right, fibrous. It links together. We'll talk about our definition in just a second. What do we think? What else? What's an example of something plastic or something plastic that you have used today? What do you think? I know that I've used, here's some plastic that I've been using. This is a little plastic zipper bag, right? Ooh, a cup. We have someone saying a cup. I have a bowl here. It's actually going to be part of the lab. But yeah, I have that bowl there. That's made of plastic. Legos. Oh, great example. A milk jug. Oh, and we have a friend saying that plastic is a polymer. Great term. So I have a couple of examples of plastic here. I have my plastic bag. I just got this one because it had some interesting properties. I also have a tray here. Oh, a toothbrush is another thing that can be made out of plastic. I love it. So plastic is something that can be, it can be kind of like stretchy and bendable, or it can be really rigid. It can be clear, or it can be opaque. We can't see through it, right? It can be a lot of different ways. And what makes something a plastic is kind of like my friend was just saying, is it's a polymer. And that just means that all of the molecules that make it up, all those teeny, teeny, tiny little pieces that make everything up, they like to kind of link together in a long chain. And in general, plastic is something that you can kind of start with it in almost a more like liquidy state, and you can mold it. You can cure it, or you can use heat. You can sort of dry it in a certain way so that it becomes rigid, right? So this was molded, and now it's no longer in a liquid state. It's in a very tough, solid state. And that's one of the most kind of incredible things about plastic is we can mold it and use it for so many different things. I have a question for you all. Do you think that all plastic is the same? Do you think it's made out of the same stuff? What do you think? Maybe no. Yeah. So we have a couple friends saying, no, I don't think it is made out of all the same things. I would agree with you. Plastic is made up of some different things, and there are some different ways that we categorize. We put them into different categories. Ooh, this is a great point. My friend was saying that these plastics, these polymers, are in many cases made out of oil. Ooh, petroleum. Yeah, exactly. So a lot of times they're made out of something really similar. A lot of times they're made out of material derived, right, taken from petroleum, oil, or natural gas, sometimes even coal. So different kinds of fossil fuels. I've heard it said before that some kinds of plastic are made out of dinosaurs in a way because they're a fossil fuel. That material is taken and used to make so many different kinds of plastic. And we'll talk kind of more about that process in just a second, but I wanted to ask all of you, what do you think? Is there a way to figure out what type of plastic something is? If I was looking at this piece of plastic, is there a way that I could look at it and just know? Is there something about it that would tell me? What do you think? Or maybe here, I also have this Tupperware container. Yeah, maybe. So one of the things I could look at is the physical properties, right? I know that some types of plastic tend to be certain ways, but sometimes they're kind of like, they're the same type of plastic in a really different form. And there's a way that I know that, ooh, the textures are maybe something that could tell me. That's true, right? Like this one's hard, and then this one's hard, but this one is more bendy. Now I can crumple it up, but then take it out. So I could put them into categories based on how flexible they are. I could put them into categories based on their color, whether or not I can see through them. I can also put them into different categories based on different ways that they're made, and I can do that by looking at a number that's on many type of plastics. Have you guys seen this number before? It's oftentimes on the bottom of your container. There's a little number. I'm going to see if my camera will focus on it here. There's a little number on the bottom, and it's surrounded by this triangle made out of arrows. It's the recycling code that tells us what number plastic it is. So I'm looking, this one is a number 5 plastic. So this one's a number 5. This one doesn't have a number. A lot of them don't have a number. I don't know if any of you at home have collected different plastics. If you're looking at it, can you tell me what kind of numbers you're seeing? What do you think? I've got something else here. I've got this bottle. This is a number 2. What do you think? Oh, I also got this. I got a water bottle as well. Let's see if this one has a number on it. What do you think? Oh, I'm seeing some. So some of us have a number 1, a 5. Oh, we have a 2 and a 5. We've got a 6. We've got a 1. What do all these numbers mean, right? They're telling us the type of plastic they are. And we're going to be able to figure out, even if there's no number on something, we're going to figure out ways that we could tell what type of plastic it is. Oh, you guys have so much plastic with you. That's perfect. So there's 6 different types of plastic, at least recyclable plastics that we'll be talking about. Maybe there's a 7th category, but 7 is really the number for everything else, right? So our number 1s are called PETs, that's polyethylene terephthalate. We have number 2s, which are high density polyethylene. Number 3s, polyvinyl chlorides. 4, low density polyethylenes. By the way, there will be a test, so you should be memorizing every single word I'm saying. I'm just kidding. 5s are polypropylene, and 6s are polystyrene. So there's, oh, and my friend just even said in the chat, styrofoam is another example. You're exactly right. Those are kind of 5 basic ones we'll be talking about today, because they're different ones that we can potentially recycle. And we'll talk about how we can tell which ones are recyclable and how we can tell which ones are not in just a moment. But there's a reason that we talk a lot about recycling. First, I might even ask you, what does recycling mean? What is that? What do you think? We talk about recycling a lot, especially when it comes to plastic. Recycling is, oh, maybe reusing something. Yeah, you use something more than once. It's to reuse plastic, right? So it's not only reusing it like I use this Tupperware container more than once, right? I buy this Tupperware container, I can use it to store things like food, I can use it to heat up food. I use it more than once. So in a way, that's reusing it. But it's also being, oh, this is good. Repurposing or making it into something else. Yeah, recyclable plastics can be broken down into that almost like liquidy form again, and then they can be made into something else. So it doesn't live just one life as Tupperware or just one life as a plastic bag. Once I have used them, I can, instead of just tossing them somewhere, instead of discarding them, I can give them to a recycling center where they can be almost like melted down and used again. Oh, I love this. We have that. The 3 R's that go together: reduce, reuse, recycle. These are great ways to kind of keep things more sustainable, to make sure that we're not that there's not too much plastic, discarded plastic all around us. Because here's the thing about plastic and why we talk about how it's so important to recycle it, is if I have something like, let's say I eat an apple. So I eat an apple, and let's say that I toss the apple core on the ground. If that apple core lays on the ground for a while, right, what will happen to it? What do you think? Will it stay there, or will something happen to it over days and days and maybe weeks? Exactly, it'll decay. Ooh, great word, it will decompose. So when I have something like an apple, I eat it, I throw it, it has the ability to decompose, to rot. That means it kind of breaks down into kind of the individual components of life. It can kind of turn into part of the soil again. It's something that will not stay in apple core forever, right? But if I have this Tupperware and I toss it outside, will it decompose? What do you think? I agree with you all. It will not decompose. So the thing about this Tupperware, the thing about plastic, is it's really good at being plastic. It can't really break down. It can't return to the individual kind of pieces, elements of building blocks of life and stuff. It kind of just stays plastic. If I threw this somewhere, it would remain plastic for even like potentially like years, like hundreds of years. Even if it did start to break apart, the little pieces of it still wouldn't be unplastic, right? It would just mean that there are smaller pieces of plastic all around. This is a great point. Like my friend was just saying, it takes a couple hundred years for a plastic item to break apart. So that's why we're always talking about how important it is to recycle plastics, right? There's this amazing invention, but when we do stuff, especially when we just use them one time and maybe toss them somewhere we shouldn't, then that's going to stay plastic forever, right? Not only does it mean using more fossil fuels, right, which are harmful to the earth when we extract them from the earth. It takes more resources to make more plastic if we just throw it away, and the plastic sticks around, doesn't decompose. By recycling them, we can kind of put them back into use as something else. Right? That's the main idea we've kind of been talking about here. This is a good point. My friend was saying some plastics can decompose. It's true that there are a lot of scientists, especially like working on ways to make plastic that is decomposable, like some kinds of bioplastics. I know there's a certain plastic that's made from, I think, maybe it's like made from corn in some way, and that can break down because it's made from corn rather than a fossil fuel. That's a really great point. I wanted to get to testing some of our plastics. You guys know a lot about recycling. That's so awesome. Oh, and even, this is a great point. One more thing. My friend was pointing out that there are types of bacteria that may eat plastic. This is such an exciting kind of discovery that scientists are researching. Could there be a type of bacteria that can break down plastic so that plastic doesn't stay plastic for so long? And these are really amazing discoveries, and it's incredible that science is continuing to innovate in this way. And in the meantime, we can also do our part. We don't have to rely on a new bacteria to break down our plastic. We can also take a role in making sure that there's not too much discarded plastic around and that plastics can be recycled and live a new life. So what I'm going to do is I'm going to talk about some of the different materials I have for testing our main 6 types of plastic. So I think all of you were saying you did have some various plastic things that you're testing. I've got some different samples. Now I have samples cut from all 6 types. So I've got a number 1, I've got a number 2, I've got, a number 3, a 4, a 5, and finally a 6. Just so that you can see what happens when we test these different ones. It's okay if you don't have all of the different kinds, but I have all of those. And I have some other stuff that I'm going to use to test them. I've got this little dish of water. I've got a little dish of isopropyl alcohol or rubbing alcohol. I just happen to have a 91%. I think probably it will, and I know that it will work with a lower percentage, but just so you know, I'm using 91. I've also got a container of some oil here. This is just regular kitchen oil. And there were a few other things I said that you certainly can have and can use, but you don't have to, right? Like I said, if you happen to have a hair dryer, that can be really helpful for testing. And I also have some tweezers to help me. You don't necessarily need tweezers, but if you are using a hair dryer and you do not have tweezers, I did recommend that you get a heat-safe mug, and we'll talk about why in just a second. Okay, so when we're talking about how on earth to look at all these different types of plastic and figure out which number they are, we can start with kind of a sinking and a floating test. I'm going to go ahead and switch to my experiment cam so that you don't have to look at me telling you what my experiment is. You can just check out the experiment itself. I'll go ahead and, that's a beautiful picture of my friend Max, but here is our experiment cam. So you can see I've got my different types of plastic here. And I'm going to start with my water. I'm going to test the density of these plastics. That means I'm going to see if they can float on the water or if they sink, right? So I think all of these different ways that we can test things, we can test every single one of our plastics. And I'm going to do that for the first one, but after that, we're going to follow a certain flow chart to see what kind of different ways we can test it, right? So just for the first one, let's test every single type of plastic. So I'm going to start with my number 1, plastic. I'm going to put it in my water, and I'm going to make sure that it is all covered in water. I want to make sure that it's not just sitting on the surface, right? I want to make sure that there's water on all sides. Can I push it down again? Does it raise back up? Or if I push it down, does it stay down? What do you think? What did you all see? Were you able to see that? Here it is. When I put it all the way in the water, it does. It sinks. And I don't know if any of you are able to test any of your plastics this way. But yeah, my number 1 sank. So I'm going to take it out and put it in a pile. This is going to be my sink pile. Now I'll take my number 2 plastic. And I'm going to see if this one floats. So I'm going to make sure that I push it all the way down. What do you think? Float or sink? Oh yeah, this one floats. So even if I push all the way to the bottom, it floats back up. So my number 2 floats, I'll put it in my float pile. Now let's do, I'll just pick this one up right here. Number 3, here we go, I'm gonna push it all the way down. And it kind of floats back up actually. It seemed like it was gonna sink, but it floated back up to the top. All right, let's try just a few more. That is in our float pile. Let's do this one right here. I'm gonna put it right in. I'm gonna push it down. We're gonna see, does it sink or float? Yeah, that one sinks. So we'll put it in our sink pile. Let's do this one. We only have 2 more. So I'm gonna take this one, make sure it goes all the way down. Float or sink? What do you think? Oh yeah, this one floats. So I'll put it in my float pile. All right, just one more. This is my last one, my number 6. I'm gonna put it on top, push it to the bottom, and see if it sinks or floats. What do you think, friends? Yep, I think that one sinks. So let me go ahead and take it out. I'll put it in my sink pile. So it happened that I had 3 that floated and 3 that sunk. And there's different ways that I could test these, right? And I could go through and do every single one of them in the different ways that we test them. But I think for right now, we're gonna go by this chart. I'm gonna switch to my face cam again so that I can show you this chart that I have. And this is a chart that I can email you all after the lab. But we already did the first one. We did the water test. That was kind of our first one. It tests the density. So if it floats, we can do these. If it sinks, we can do these. Let's talk about testing our sink pile. So after we test it to see whether or not it floats, right? If it sinks, we still don't know exactly what type it is, right? There were 3 of them that sunk. So what we'll do is called a copper wire test. Now, I didn't ask you guys to get any copper wire to do the copper wire test because it's one that involves fire. So that's not one that I'm allowed to do at the museum, but it is one that I recorded myself doing at home. So I wanted to show you just a quick few seconds of a clip that shows you what happens if you take your plastic that's sunk and you test it with a copper wire. What you do is you heat this copper wire up until it's really hot. You touch it to the plastic you're testing, and then you put it back inside of the candle flame, and you're looking for a certain reaction. I'm gonna go ahead and play my clips so that you can see what the certain reaction was that I got. I'm gonna go ahead and share my screen. So here's my copper wire. You can see that right there. I'm holding it with a pair of pliers and I'm testing it with a candle. And I'm gonna get it nice and hot. And let's see what happens. So I got my wire nice and hot in the candle, and there's my piece of plastic that I'm testing. And when I touched it, the copper was so hot that it melted a little bit of the plastic. And now I stick it back in the flame. And tell me what you see happening. What do you think? Do you guys see that? Do you see what cool stuff is going on there? So it was a little hard to see in this clip. So I did it again. I did just the flame part so you could see the flame reaction. Let's take a quick look at that. Ready? This is that same chemical reaction we're going to be looking at. See what you notice about that fire. What do you think? Is that normal fire? Does fire normally look like that? What do you think? Very nice. I'm gonna go ahead and stop sharing my screen. Yeah, great observations, my friend. The fire turned like a bluish, tealish green. So that certain reaction, that bluish, greenish flame, is a reaction that tells us that it is a number 3 plastic. There's just a chemical reaction that occurs with that hot copper wire that tells us that that's a number 3. So if we do our flame test and it has a green flame, we have already identified our plastic. If it just burns like an orange flame, or if it doesn't burn at all, if it just kind of like melts or maybe smokes a little bit, then we have to do another test. And for this test, we're going to use another chemical that I thought that I would show you guys, and maybe you can do it yourselves if you would like to, but since we're going to be working with heat shortly, I didn't want to have too much acetone or nail polish remover. I didn't want to have too much of that near our heat source. So I'll show you what that looks like. I'll go to my experiment can. Beautiful. So I'm going to take my tiny thing of acetone, right? That's kind of the stuff in nail polish remover. And I'm going to take one of my plastics and I'm going to dip it in to my acetone. And I want you guys to tell me what you see happening. What do you think? Do you see anything happening? Here, I'll show you a different one. So here's our first one that we tried. Let's try, there we go, this one. What do you think? Did they do the same thing? They did a little bit, right? One of them both floats in water and has a reaction with the acetone. Yeah, it gets kind of foggy. I'm gonna even dip the whole thing so we can see it. It takes a second, but then it turns this kind of foggy color because the acetone is actually kind of almost like melting it a little bit. So we know that if it both floats in water, it does not create a green flame, and it reacts with acetone. That tells us it's a number 6. So that's how I know this is a number 6. So let's do one that you guys can actually do with me. I'm going to do a heat test. So we've tested a whole bunch of plastics. We've seen if it sinks in water, if it has an orange flame, if it doesn't react to the acetone. We're going to try testing it with heat. And instead of using something like a candle flame, we're going to use our hair dryer. So I've got my hair dryer here, and I'm going to test one of my plastics. So I'm going to grab this one, just if I can. I'm going to grab this one, and I'm making sure to grab it with my tweezers because I don't want my fingers to get too hot. This is one where if you're not using tweezers, I would recommend putting your piece of plastic into your mug, and that way you can kind of stick the hair dryer down in there and it will push the piece of plastic down and it will be nice and hot and get the plastic hot without getting your fingers hot. But I'm going to show you what happens here. So I am going to turn my hair dryer on, and with what Zoom is going to do is it's going to make it loud for just a second, but then the sound kind of goes away. So I'm going to have my plastic here. I'm going to turn my hair dryer on. It's on its hot setting. And you can tell me what you observe. Ready? Great observation, my friends. Well, first of all, it blew away my experiment circle. What I'm going to do is I'm going to dip it in a little bit of water just to make sure that it's nice and cool for me to touch. But yes, great observation. It starts getting bendy. Very nice. So it starts getting a little bit bendy. That's something that tells us that this is a number 1 plastic. Right? There are other plastics that react to heat, but this one sinks in water. It has an orange flame in a copper wire test. It does not have a reaction necessarily with acetone, and it does bend in heat. Now, we're just going to test 2 more. So 2 more tests really quickly. They're both density tests. So after we tested with the water, we're going to test with our actually, I want to make sure that this is the right one. Nope, that one's my water. It's tricky. This is my isopropyl or rubbing alcohol, and this is my oil. Quick question. Do you guys know which one is denser? Which one is denser? Is it the alcohol or is it the oil? 50-50 chance. We can just guess. It's okay if you don't know. Yeah, I would agree with you. The oil is denser. That means there's more molecules, there's more stuff in it per area, right? So this is about the same amount of both liquids, right? But this one has more of its molecules in there. So this is denser. right? Oil is more dense than water, and alcohol is less dense. So let's test our ones that floated, right? I'm going to test this one. And I remember that this one was in my float pile, and I'm going to test it in isopropyl alcohol. Sink or float? I saw it sink. I don't know about you guys, but I saw it sink. I'm actually even going to try it again in my water to show that it floats in water, but it sinks in alcohol. So that tells me that this is a number 2 plastic. Very nice. All right, let's test our very, very last one. We are going to test let's test this one. So this one in water, right, it kind of sinks a little bit. Well, this one floats a little bit. This one floats a little bit. So let's try this one. Oh yeah, we're looking for it floating in water, but we want to see if it sinks or floats in oil. So we've got our piece of plastic here, and I'm going to see if it floats or sinks. What do you think? And I can even test that other random one we had. What do you think? So the one that sunk was our number 4 plastic, where the one that floated is our number 5 plastic. The sinking and floating ones, to me at least, aren't quite as exciting as the ones where we get to melt stuff and light stuff on fire, but it is a really quick and easy way to be able to tell if your plastic is lighter or denser or less dense than water, oil, or alcohol. I'm gonna go ahead and bring my camera back here. There we are. Really quickly before we go, we went a little bit over. Thank you guys for sticking with us. Did anyone do this along with me at home? And were you able to see if they sunk or floated, or did you test them with heat? What do you think? Anyone able to do one like that? I know that this is kind of one that keeps your hands kind of busy, so maybe it will be a little hard to type. Oh yeah? Which one were you able to test? Oh, it sounds like a lot of people were able to test. The water one is kind of the easiest one to do. That's the one I would recommend if you're just starting, because you can pretty easily separate things into a sink pile and a float pile. Very nice. Yeah, and that's okay if you're going to try it later as well. And again, it'll be a little bit easier if we use this flow chart, which I will, of course, send after the lab to your emails. So I will make sure that you have access to this chart so you can test all sorts of different plastics at home. We just kind of we tested a small range of plastics to see what type they were, because the type they were tells us whether or not they're recyclable, right? Generally speaking, ones like 1s, 2s, and 5s, those are pretty easy to recycle. It depends on what can be recycled in your area, because it's different like county to county. But 1s, 2s, and 5s are generally pretty easy to recycle. 2s and 4s can be recycled, but sometimes only at like specialty recycling places. This is stuff like number 2s or like plastic shopping bags. Those can be recycled not you don't kind of put them out to be picked up by the recycling truck, but they can be returned to stores to be recycled. So 2s and 4s can be recycled, but it's kind of a specialty thing. You take them to a certain place. And then 3s and 6s and 7s, which we didn't talk about too much today, those are all ones that can be recycled, but are a little bit harder to recycle. So I would encourage you to look at whatever county you live in, to look up the specifics of your recycling code, because it's different everywhere, different places where you live. But in general, that's our rule. Some are easier to recycle and some are a little bit harder, and then some can be recycled at a specialty facility. Okay, so we've talked a lot about plastic today. You all had some really amazing ideas. You knew a whole lot about recycling, and especially about ways that plastic can affect our planet. And now we know about some ways to figure out whether or not a certain piece of plastic can be recycled. This is really cool. We have one of my friends here in the chat just mentioned that their primordial soup had turned orange. That's so cool. That was a previous experiment we did. I would love to, maybe next time I will show my primordial soup. We made a Vinogradsky bacterial column. We can always look that one up on our YouTube. It's called Primordial Soup, and it was a really cool experiment. I'm so excited that you kept up with it. Thank you for letting me know about that. That's awesome. But yes, I hope that you will join us again for Lab at Home. Next week is going to be Little Lab. So next week we're going to do Little Lab, which is for slightly younger. So you're certainly welcome to join us, but it's for slightly younger scientists. Whereas the week after that, so not next Tuesday, but the Tuesday after that, will be Lab at Home again, and we are going to be making bioplastics. So we're not just testing plastics, we're going to be making plastics out of stuff we can find in our kitchen. I really, really hope that you guys can join me then. Thank you so much for checking this one out, especially since it ran a little long. I really look forward to seeing you maybe next week and at least the week after that. All right, I'll see you later, friends. Thanks so much for coming.